these are the answers for exercise 12.2. Now, the question that we need to answer basically is, why did the teacher wear sunglasses? And we are given the following triangles and then also the following table where we have to solve for the variables and then place them across from the answers. Okay, so we're going to start with this triangle, and this is the t value that we need to solve for, and this t value is the long side of our right angle triangle. So in using Pythagoras, we have the following relationships. R squared equals to x squared plus y squared. So t squared is equal to 1 squared plus square root of 3 squared. So that means that t is equal to the square root. If I just simplify this, 1 squared is 1, and the square root and the square just cancels out, so that's plus 3. So this then gives me the square root of 4, which is equal to 2. So where do I see a 2? I see a 2 over here, so then I just put my t right over there. Alright, so now let's look at the next one. We go over to this triangle. So we need to find g, and g is one of the shorter sides. So I'm going to say that g squared is equal to my long side squared, which is the square root of 9 squared, minus my other short side, which is square root of 8 squared. Alright, so g is then the square root of, so let's just simplify this again. These two will cancel out, so that's 9 minus, and these two cancel out, minus 8. So this gives me square root of 1, which is just equal to 1. So where do we see a 1? We see a 1 over here, so that's where g belongs. Okay, so the next one, we've got this triangle that I'm going to work on, and we need to find a b. I think that's a b. So we've got a long side, b is the long side. So we've got b squared equals to 7 squared plus 2 squared. So the two shorter sides added together. So b will then be equal to the square root of, so 7 squared is 49 plus 4, which is then equal to the square root of 53. So where do we see that? So if we've got a 1 over here, and then we've also got 1 over there. Okay, so next triangle is this one, and I think that's an e. So, and e is also the longer side, so e squared is equal to 5 squared plus 12 squared. So e is equal to the square root of 25 plus 144, square root of that. So let's just put that on the calculator. I think 169, I think that's going to be 13. So this is then 25 plus 144, and that is equal to 13. So 13. So where do we see a 13? Here, and here, and here, and where else? I think those are the only 13s. Okay, so moving on. Here we have the following. Let's work with this triangle now. So that's a I, and this is a short side, so I squared is equal to my long side, so that's 10 squared minus 6 squared. Now I squared, or I, will be equal to the square root of 100 minus, and this gives me 36, and then this will be 64, and then that would be 8. So where do I see an 8? We have an 8 over here, and I believe that's the only 8. Alright, so next up we've got this one. That's a C. So, and this C is a short side, so we've got C squared is equal to the long side, 25 squared, minus the other short side, 7 squared. Oops, that shouldn't go there yet. Alright, then C is equal to the square root of 25 squared minus, let's just say 7 squared and put that onto the calculator as is. So we have square root of 25 squared minus 7 squared, and that would give us 24. So this is 24. Alright, so 24 over here, and then over here. Right, that looks like it. Next up is this triangle. So that's a H, and that's the short side. So H squared is equal to the long side 5 squared minus the other short side squared. So this is then, H is then equal to the square root of 25 minus 9, and this gives me 16, square root of 16, which is equal to 4. So where do I see a 4? Over here and over here. Yes. Okay. Now the next triangle is over here. So this is an O, and that's the short side. So O squared is equal to my long side 10 squared minus the other short side. So that's a square root of 51 squared. So O is equal to the square root of 100 minus this, these guys will cancel out, minus 51. Okay, so let's put that into the calculator. Or actually that would be, we don't actually have to do that. This would be 49, and then that would be 7. Okay, so O, where do I see a 7? Over here. Then we move on to this triangle. That's a W. So, and that's a long side. So W squared is equal to 6 squared plus 3 squared. Now W is equal to the square root of 36 plus 9. And that's equal to 45. Square root of 45. And I see square root of 45 over here. So I'm going to put W over there. Okay, next up is this triangle. That's a U, and that's a short side. U squared is equal to my long side, so that's 16 squared, square root of 16 squared plus, that's the short side, so minus, this is my long side, minus the other short side, 7, square root of 7 squared. So U is equal to the square root, so these guys will cancel, that's 16 minus, and these guys cancel, minus 7, and that is then equal to the square root of 9, which is equal to 3. So I have a U over there, and that seems like the only U we've got. Then moving on, this is an L, short side, so L squared is equal to my long side squared, 61 squared, minus my other short side squared, 60 squared. So L is equal to square root of 61 squared minus 60 squared, and that is equal to 61 squared minus 60 squared. This gives me 11. Right, so for L, there's 11 over here. Right. Then let's do this triangle, and that's an A, and it's the long side. So we've got A squared is equal to my two shorter sides added together, 9 squared plus 40 squared. So A is the square root of 9 squared plus 40 squared. So this gives me then square root of 81, or 9 squared plus 40 squared, and that's 41. So this is equal to 41. So I have a 41 over here, and I've also got a 41 over here, and then also there, and that seems like it. Yep, that seems like it. Okay, next up. So this triangle then. And that is a S. So that's a short side as well. So we've got S squared is equal to my long side 15 squared minus 12 squared. Right? And then S is equal to the square root of 15 squared minus 12 squared. So this is then equal to 15 squared minus 12 squared. So that's equal to 9. So where do we see a 9? We see a 9 here and here, over here, over here. Yeah, those are the 9s. And then finally, we have the r to solve. Also alongside, so r squared is equal to my two short sides, 4 squared plus 1 squared. And then r is equal to the square root of 16 plus 1, which is equal to the square root of 17. So that we see over here and over here. And this is the final answer then.